Hello and warm welcome to everyone. Today we will start the 26th lecture of this course on financial econometrics. So today basically we will start a very important uh, part of this course, which is will be the large part of this course, that is the time series analysis. Let's have the outline uh, of this lecture here. So basically, we'll first discuss what is the time series, what we mean by the time series, then the certain characteristics and properties of the time series. Then we will be also talking the different components of the time series. Then the two important aspect of the time series modeling, that is the one is the visualization, and second we will talking about the transformation of data or series. So let us talk about what is time series. So before that, first let's discuss what we mean by the data and information. Basically, when we say data, data is the basically raw and organized uh, information on any particular subject. It could be stored either in the numeric, it could be an image, it could be a graph, anything which is unprocessed, unorganized. We cannot infer any sensible conclusion from this, that what we call the data. However, when we process the data, when we organize in a certain way, then we get a certain conclusion about the incident, about those observations, those phenomena, those process. That's the basically information. So if we see our objective here will be to process the information from the data. So one of the organization way how we organize is concerned about if we organize the data, those observations according to the time. So that is known as the time series. So what we can say, data collected at the different points of time, or we can say data arranged in a chronological order, is known as the time series. So that this time period, it could be month, it could be year, it could be day, it could be minutes, or it could be even the per seconds. However, in a particular series, the that difference, the time gap from one observation to another observation will remain constant. So that means if one series we have, that will contain the data on a particular specified period. Let us say if it is monthly data, so that means from one observation to next observation, the time gap will be 1 month. We cannot have in one series some of the observations, between some of the observations the time gap is 1 month, and some of the observations it could be one day. We can't have that. So time series basically we organize the data in a chronological manner, and the gap between the two observations remains constant for over the period of time. Now we can think of other way also. So this time series data is basically being generated by a stochastic process or the data generating process. So what is an stochastic process? See, to understand the stochastic process, let us think of a GDP of India. So let us say we have a GDP of India. So in 1990, in the 1990, let us say we have GDP of 2000 crore. In 1991, it is, let us say, 2010 crore, so on so forth. Let us say till 2000 we observe the data. So in the 2010 it was 2200 crore. So however, if we think this way, in 1990 the value of GDP, it could have been 2001, it could have been 1990, it could have been 1015, it could have been anything. So there was the possibility of generating, taking any number of the GDP. So that means that at the particular year GDP could have taken any value. So that means that the different process, GDP process could have taken any value of that. So that whole possibilities, if we club in, so that is known as the data generating process. So we could have been anything here. Let us say we can say X1. Then similarly here in 1991, then up to, let us say, this. The another possibility could have been x2. So the series like this. So there is the possibility of any value to take. However, what we have done here, we have realized this particular one observation for that particular year. So this entire possibility of generating the data is what we call the data generative process. However, what we have this single series out of this infinite possibilities. So that single series, that specific one realization, what we have, what we call the time series. So in that sense, we can say that time series is a specific realization of the data genetic process which we observe, which we record, and we arrange that in a particular order. So that is the time series data. For example, stock prices, money supply, inflation, GDP, sales over the years for a particular company. So all those comes an example are example of the time series data. Now, why we are concerned of the time series data? What are the importance of the time series data we have? See, the time series data is very important on certain ground. For example, it helps us to understand the trends and patterns. The time series analysis helps us to identify the trend, whether it's, we'll see in a minute, whether it's a trend is upward, whether it's downward, what phenomena we have, how it is the process, how the data is being generated. If we know that, then we will be able to use to predict. So comes the forecasting the next. Another importance of the time series comes from this, that in the previous week we have discussed about the OLS, ordinary least square. So where what we have discussed that yt is the function sum of xt. So to predict or to know the behavior of yt, we must have data on xt. Then only we will be able to use the OLS methodology or OLS technique to estimate, to know about the behavior of yt. However, there are many variables which is not available. So in that case, it becomes difficult to know about the yt. However, using the time series analysis, we will be able to know yt even if we don't have any factor here. That basically enhances the importance of the time series analysis. Another is identifying anomalies, abnormalities. So identifying anomaly or abnormalities gives a lot of have a lot of implications, especially in the finance. For example, insider trading or even studies, all those basically finding the anomaly over the period of time, over the specified period, we can see that. So the time series analysis also helps us to find out that whether have been some anomalies, are there any abnormalities in this particular time series. Then the most important and the widely used is the time series has been used for the forecasting. So based on the basically historical data, we can make the forecast about the future. We can predict about the future. Then once if we are able to predict the future, that means we may have the better plan. We can manage whether it's the crisis or whether it's for the particular company's sales prediction, whether it's revenue prediction. So then planning becomes easier. We can plan ahead. So the time series has these are the importance for which we will be focusing much on the time series analysis in this particular course. Now, before starting the modeling aspect, let us discuss the certain characteristics or properties of the time series analysis. How it is different than the other analysis. Why we need a separate tools and techniques to analyze the time series. To understand that, let's discuss some of the properties or characteristics of this. So, the time series data we know are ordered in the time. That means it reflects the influence of the previous observation on the current observation, or we can say previous observation on the future observation. And why that have? Because of the structure we have of the time series, where we order the observations based on the time, and because of that it has this inherent property, and this inherent property sometimes is basically beneficial for us and sometimes it may create the problem. So that means there will be correlation between the observations. So if there is the correlation between the observations, you might remember in case of OLS, one of the, or we can say the classical linear regression model assumptions, there will be the violation of because of this property. What is that violation? We have assumed that in OLS that residuals are independent, that is they do not each other, on popularly we know that there is no autocorrelation among the error term. However, here we are saying that in the time series, one of the characteristics that the previous observation do have effect on the future observation, or we can say the current observation do depend on the previous observation. That means in most often in case of time series, this violation is this assumption gets violated. So in algebraic form, you must remember this thing, that is covariance between ui and uj is 0 when I is not equal to j. So that is basically no autocorrelation. Then what implication it will have? Once this assumption is violated, then the values of f and the t statistics are overestimated. That means the estimates which we are getting may not be reliable. Then for example, we can take say BSc 100, we have taken the data from 2000 to 2024. This is the monthly data. That's how it looks like that. So a lot of the things we will unpack using this particular series in this lecture. So the another property of we have the time series data often have the time dependent moments. What in moments basically mean, variance, skewness, kurtosis, these are the moments, and we use these things to characterize the data, to characterize the distributions, to specify the feature of the distributions. So when we say time dependent, that means as the time passes, the moments of the particular time series may increase or decrease along the time paths. So that means as the time varies, these moments also varies. Therefore, we call it as time passes, as time varies, these moments also vary. Therefore, we call these moments are time dependent. And this property, what we call the property of non-stationarity. And we'll see in coming lectures, this property of non-stationarity is basically a very undesirable property for the modeling we have. So, and another problem we have, if the data is non-stationary, then if we draw a linear regression between the two non-stationary series, then that OLS will be spurious regression. Spurious regression means statistically you will find that there is the relationship that because of both the series are following the time trend, both the series are increasing, but in actual sense there is no relationship between these two variables. However, if you run OLS, the coefficients you may get statistically significant, R square you may get quite good. However, that is happening because of the statistical nature of the data. Okay, both are trending in the same direction or in the opposite direction. However, inherently there is no relationship between these two series. For example, let us say if you regress the population of penguins in Australia on the population of India, so what we can observe, there is a very positive trend among these. Does this mean the population of India do have effect on the population of penguin? No, it doesn't mean that. And why we got the relationship statistical significance? Because these two are the non-stationary series. So such kind of relationship is known as the spurious regression. And we know in time series, this is the inherent property. So that means in the time series, we may or may not use the OLS. Then the statistical characteristics of the time series data often violate the assumptions of conventional statistical methods. Therefore, we need special time tools, techniques, methods to analyze the time series data. And in the coming lectures, that's what we are going to do. We will try to discuss the different evolvement of the methods and techniques which has been evolved specifically for the time series data. Then time series can be decomposed into the different components, and these different components represent different aspects of the data generating process of the data. Time series can be decomposed into the trend component, seasonal component, cyclical component, and the random component. In brief, we can say this trend component basically represents overall persistent long-term movement in the particular time series. Whereas the seasonal, it represents the periodic fluctuations or the regular fluctuations. However, the duration of the fluctuation is less than a year. If the similar here, the repeating swings or movements over more than 1 year if we have, then we call the cyclical fluctuations. So that is the cyclical component we have. At the last, which is very important for us, that is the random component, or you can say irregular fluctuations or residual fluctuations. So let us briefly discuss these different components here. So the trend component is basically overall decreases or increases in a series. So increase or decrease here, and that period we will take, usually it will be a long period of time. So it could be upward trending, it could be a linear or non-linear, or for example here we see here, so this is the exponential trend it is following. Here we can say it is a linear time trend, and here we can say it is a nothing but the logarithmic trend. However, it is exponential upward, it could be exponential down. Here it is a linear upward, it could be the linear downward. So a long-term persistent overall observation, if we see, that is basically what we concern about the trend. So this is the trend component of a time series. Similarly, what we have seasonal component. So as already we have discussed, it's a very short-term wave-like phenomena pattern and usually repeats within a year. So here often we will be able to find if the frequency or the time of the data or the time period is quarterly or monthly. Even in the daily we can observe, but quite often we find in the monthly and the quarterly data. For example, let us take the electricity consumption. So yes, over the years it may increase as the population increasing, as the family members are increasing, as the income of the people are increasing. So the electronic gadgets, the items we consume, the electricity may increase. However, there will be the certain pattern. For example, what we can say, in the winter it will be more because we may need for the heating of the water. However, in the spring it may fall because as we do not need now the electricity for the heating purpose. However, in the summer we may again see a spike because of the summer we need the cooling. On the other hand, in the fall it may again fall. So basically we'll see here from winter to here, we can see from fall to fall, here a pattern we are seeing that. So again this same pattern. So here this same pattern is repeating here also. So this is an example of the seasonal component of data. So if the time series behaves like that, so then we call this is the seasonal component of the particular time series. Then another we have the cyclical. So as like the seasonal component, only thing here it will be the time period will be more than 1 year. So the time period will be more than 1 year, and the terminology has changed. For example, here this is known as the trough, whereas this is known as the peak. And here we measure one cycle from either peak to peak. So this will be the one cycle, or we can measure from trough to trough as the one cycle. and the period from this to this will be more than 1 year, that we sure. However, here, as in the seasonal case, the period is same for 1 year, for example, quarter to quarter, quarter to quarter. However, here, this period to reach this one cycle, it may not necessarily will be the same. That means length of cycle may differ over the period of time. Then the last of the component is the irregular component or the random component. So basically it is unpredictable, random, what residual fluctuations. So what we call the noise in the time series. So a broad objective of modeling is basically to know the behavior of this random component. If you are able to find this behavior of this random component, that means we will be able to find out the pattern of the particular series, because this trend, cyclical behavior, those things easy to find. Here it will be little difficult. So the most of the modeling aspect goes to basically find out the behavior of the random component. Once we are able to do that, then the other components we add, and we'll be able to identify the pattern of behavior of the time series. Then one of the major aspect in the time series modeling, one of the important aspect in the time series modeling comes the visualization of the data. So what is visualization? Basically we can see here the plot, or we can say the time series plot. So plot means basically two-dimensional plot, where on the vertical axis we measure the variable of interest, for example GDP, inflation, money supply, stock prices, yield curve, bonds return, all those things. The horizontal axis corresponds to the time periods. So that is basically what we mean by the plot here. So plot of time series, or what we call the visualization, provides a very preliminary tools for detecting of the data. So what it helps us? It helps us, this plot or this visualization, whether the data is mean reverting or has explosive behavior. So these things in a minute we'll discuss what we mean by the mean reverting, what we mean by the explosive behavior. Then has a time trend, or it exhibits seasonality. Does it demonstrate the structure breaks? And basically once we have this information, this will help us to which kind of, how we will be testing, which kind of test we should use, what should be the diagnosis elements, what are the concern we should clear before using that model, or what different kind of estimation methods will be used, which is the more appropriate technique we will have. So all these will be quite easy to identify if we know these aspects. And these aspects we can measure or we can identify using the visualization of the data or plotting of the time series. And in fact, Sume and Stoffer has said, in our view, the first step in time series investigation always involves careful scrutiny of the recorded data plotted over time. Basically, this scrutiny often suggests the method of analysis as well as statistics that will be used in summarizing the information in the data. So the first step in the time series modeling is basically visualization of data, and it's a very important and critical aspect. Some often says that the 50% of the modeling aspect or analysis aspect comes from the basically plotting of the data. If you are using appropriate plot, then it becomes easier, that half of the work you have done. Then, for example, mean reverting. What we mean with mean reverting? Mean reverting data returns over time to a time invariant mean. For example, if we say, see this data, what do you think? Is it a mean reverting or it is a non-mean reverting? So mean reverting data returns to over time to a time invariant mean. So if you see here, mean means basically we are taking the average of this series. So if you see here, some of the data are lying here, this part, and some of the here, and again some of the here, some of the here. Basically, if we take average of this data, the average is fixed around the 50. So as time passes, the mean of this time series reverse back to this mu is equal to 50. So that means this series exhibits the mean reverting. So any series which have the graph like this, the series is mean reverting. That is, in the long term, it has a static mean. The mean is not time dependent. So, for example, if the series is non-mean reverting, that means it will be non-stationary. And we know that if the data is non-stationary, then we can use the unit root test to identify the non-stationarity properties of the particular time series data. So that means plotting will help us to identify whether the series is non-stationary or not. If it seems non-stationary, then we can use the unit root test to identify the non-stationarity or to confirm the non-stationarity. So it guides us to ask that. Then, for example, time trending and the seasonality, these things already we have discussed. So, for example, any series which behaves like this, so that means as the time passes, either it follows the upward trend or it could follow the downward trend. So those are the basically trending. And if the data is trending, then we'll see in the coming lectures, then we have to take care of that and we have to adopt the certain component in our modeling. Similarly, if there is the seasonality in the data, again we have to adopt the we have to tweak the models. We have to change our models to incorporate the seasonality property of the particular data. So the presence of the time trend or presence of the seasonality do have impact how we build a model. Then the other aspect is the structural break. What is structural break? Basically a sudden change in the behavior at a certain point of time, structural break. For example, you can see this data follows up to here, then there is the sudden shift here from this point to this point. So this sudden shift is nothing but is known as the structural break. Now, if we have the structural break in the data, then it can create instability in the parameters of any model. For example, OLS we estimate, so we will get the coefficients alpha and beta. Those are nothing but the parameters. But if there is a structural break, then those parameters will not be stable. So as we change the sample, those parameters may change, so we cannot get the inference. Then in turn can diminish the validity and reliability of the particular model. So the presence of structural break do have effect on the our model. How we use that model, that will be also affected. How we get the inference, that will be also gets affected here. And how we can find out, one of the way to identify is the visualization here. Similarly, then another aspect of the time series analysis is the basically transformation of the data. There are the certain aspect, certain way of transforming data which have a certain specific effect on the original data. To understand that, let us say this is the quarterly series of GDP of a particular country, and we have plotted this for let's say 80 years here. So this is quarterly data. So basically we have 80 quarters data here on this screen, and it shows like this. So now what we can observe here, we can observe here, so the visual, the time series could be label, at label we can change, change the it could be relative and absolute. So these are the certain way of the we can transform the data. However, what we observe here, one thing we observe, there is the positive trend into the data. As time passes, it is moving upward. So we are sure here is the positive trend in the data. Do you observe the seasonality pattern here? So if you observe here, so yes, there is the seasonality pattern here. So let us say from this point to this point, you can say similarly this point. So similarly, so you can say here everywhere there has been the same behavior it follows. And we, as we discussed, quite often it is present in the quarterly data. So here is the quite strong chance we have. Okay, this shows the seasonality here. Yes, we do have seasonality in this particular data. Now let us say if we change this data into the absolute change, that is we change the data GDP. Now This series represents the delta GDP, that is the GDP of this quarter minus the GDP of the previous quarter. So what we can observe, there is no more trend. So trend has been eliminated. So if we take the absolute change from the current observation on the previous observation, we see there is the removal of the trend. What about the seasonality? Do you think the seasonality has removed? No, still the seasonality is present here. Now, another thing what we can observe, it fluctuates around the mean, this 0. So we can observe the mean is 0. That means the mean is no more time dependent. Do you think the break? Yes, we can observe here. There is the still break here. You can observe. So by the absolute change, we have not removed the seasonality. We were not able to take care of the break. Only thing what we are able to do, we have eliminated the effect of the trend. Now let us say if we take the relative change from quarter to quarter, in another sense the quarterly growth. So that is, we will use this formula. So we take the quarterly growth. However, this is what we know, the discrete growth. We have also discussed in the previous lectures. We can have the counterpart of this. Alternative is what we call quarterly growth. We can calculate. So this is known as the continuous quarterly growth. So either way, either you can use this or we can use the logarithmic form. In both cases, what we can observe this. So one thing, there is no more trend. However, what about the seasonality? You can observe, yes, still there is the seasonality. However, the presence or the effect of seasonality as time passes has decreased. So as time passes, the effect of the seasonality has reduced, has decreased. Now let us say what we do. We don't take this quarter's difference, the previous quarter difference. We use this same quarter of the preceding year. So basically, the first quarter of this year, then the reference of first quarter of the previous year. So the 3 quarters here we are leaving in between. So what we can observe here, this is known as the annual growth rate. And obviously corresponding of this, we have the logarithmic form of this growth here. Now what we can observe here in this case, this is the annual change. Note the quarterly growth rate is the annual growth rate. Another thing, now you can observe there is no more seasonal effect in this particular data. So if we using this particular way to transform the data, we can eliminate the trend as well as we can eliminate the seasonal effect. What about the break? Break is still there. However, we may think of eliminating the seasonal effect but not the trend effect. That could be achieved using this particular formula here. Because it is a quarterly data, so what we take the 4 observations, then we take the average of that 4. So 4 consecutive values of the time series are added to avoid the shift in the label and divided by 4. So in this case, what we have, that we are able to eliminate the seasonal effect. So we are able to remove the seasonality. However, the trend, which was the upward trend, still it is intact in the data. This is basically also known as the unweighted moving average. So basically today we have discussed what is the time series, what are the different characteristics of time series, what is the importance of the visualization in the time series modeling, and what are the basic transformations we needed and how it affects the different aspects of the time series data. In the next class, we will be discussing about the different modeling aspect of the time series data. So thanks a lot being with me. Hope you are enjoying this course. See you in the next lecture. Thank you.